Hello guys, welcome to part 13 of the Olga ww2 project. I left you with the same side I believe. No, not completely. Well, I added some parts here, so I connected the wires up on the back on that socket there. I put some extra cooling on there because of our short circuit that we had with our transformer. The whole thing was hot. That was on 2 amps, more than 2.5 amps, so that got hot. So I went to the shop and bought some elements to cool it, and I bought some more stuff here, some capacitors. I'll show you. They were quite big capacitors really, and I'm going to put them in here on that side, on the transformer, on the secondary ww300, so we'll ground them, and they are 1500 volts I suppose. Yes, they are 1500 volts. I think that should suffice, and yeah, I'll have to look then when we've done that to connect this socket up here. Well, that's well straightforward really. That is the filament and our high voltage from the first electrolytic capacitor and the second electrolytic capacitor. So well, there is not much to tell really if I'm going to do this. I put the 6 amp fuse in here just to protect the lot, so if I on a battery, then my amps will run away as soon as something goes wrong with the transformer, for instance. Well, we had that before, as you know, when we go through our protection on our low voltage power supply. Nothing really bad happened, so it didn't go up in flames, if you know what I mean. So we do our best, as always. Now to show you on the bottom what I've done, and that is to remove the hash out of it. That's our core, what we need underneath. So and then I have to fit all the other parts, so I will come back to you when I've done this all, and then we run another test and see if our transformer will survive. I presume we will, because of it is protected. And then when we leave our valve off for that moment, I will connect up our receiver with the filaments on this transformer and see what happens then. See if this gets warm or hot or whatever it's going to do. You have to make sure we know all things what can happen. So anyway guys, I will close the video down for a minute, and I will proceed with constructing and put our see, we have another point here with our choke. See if we have room enough to I have to make room enough. Yeah, that'll work. Yeah, you see, when you do something, you have to think about twice. Think twice about what you're going to do. So we'll see. Okay, it will shut down, and I'll come back to you. I have more. Hi everybody. Well, I just wanted to show you how far I got. So I put all the wiring in here on top for the filaments, and I put our high voltage in, our capacitors. Our 2 capacitors are necessary to protect the transformer. And what I have to do still is solder this socket. That's all, the wires are in there. So the next thing to do is to wire this choke up, put them through that hole, and then yeah, See if I get the wires back from the valve. So I have to do that on the bottom. Oh yeah. So the wires are there, you can see. The wires are there for the filaments, and the high voltage are there, so there are going a few capacitors in there. Let's have a look. 2 electrolytic capacitors and a normal capacitor. That's about it. Probably also a choke one 2.5 millihenry because of RF what gets into the system. So see if that is necessary. And when I've done all that, I will solder the socket and put that choke in its place and connect it all up. And then we will test our power supply. Okay guys, I'm going to do that next, and I'll see you when I've done that. Okay. Hi everybody. Well, you can see I was nearly there with my power supply. So I start checking the connections, and between those two capacitors here, from cathode to coil, one coil back to the second ones, it was open. Oh yes, it was open. Yep. So I'll show you. I will turn up the camera a little bit. Hold on. Well guys, as I said, the core was open, and I knocked them out. Just the core of it. The other part's still in here. So I'll show you. That's our spool, and I'll show you with my meter. See if we can get this. Oh, all the rubbish on there. It's unbelievable, isn't it? Okay, let's see if we can see this. Not really. Oh, now you can. Okay. Anyway, I'll show you. The damn thing is open, and that's really frustrating, you know. I'll connect them on there. Nothing here. There's nothing. Absolutely. On 2K or on 2 Mac. Nothing. Well, we have something here. Oh, hooray! 200K. Well, you get the picture. The thing is open, so should be a couple of hundred ohms or something like that. So there we go, guys. We have to have a new job. So we have to rewind this spool and then put it all together. So the question is if this core is still in one piece. So I left them there in there. So I will put them back like that, and then hopefully it will do his job again. So we have to see if that works. Anyway guys, I have another core if I have to with former, but it's a little bit smaller. And the point is, I don't have anything to fix it with. So anyway, I won't, no, one way or the other, I have to rewind this coil. Okay. What I'm going to do next is to undo this all, get all the wiring off, get my machine on the table again, and I will start off our rewinding. So there's only one coil. It is about what is this? 0.2 mil thick wire. So I will use the same wire, and I will try to reinforce this spool again. This is really frustrating, you know. This is really frustrating. I was hoping he was open here on the top, but there's nothing to see. So there's on the bottom is where he is open, so that's where he is broken off or something like that, or inside. Anyway guys, so far so good. I'll come back to you when I have rewound this cord, put it all back together, and I can show you then that it works, okay? Hi guys, as you can see, I've started off on the rewinding of that coil, so it will take me a couple of hours, perhaps half a day, to get this done, and then I will reassemble them and put it back into our power supply. So that now I want to say something more about this coil. I bought that from the dump, actually. Just you come across that and you find that and you think, okay, nice coil. No, not a nice coil, no coil at all. So actual fact, you should test this choke before you even buy it. But there we go, those things happen, there's nothing you can do about it. Anyway guys, I will finish this and I'll come back to you. Hi everybody, now we're nearly the end of our coil. We are at 2860, sorry about that. That means our coil is nearly completed, so I will go to 3000. I will finish up and then I will resolder everything and put the coil into it again, and then we will test them on camera. Okay, so I'll see you in a minute. Hi everybody, welcome back again. That was a couple of seconds ago for you, but for me a couple of hours. So you have to report something on this. You can see I put them together. It's not put together as it should be though. I damaged the former, so I did discover that when I took it apart from the winding machine. So it was in a beautiful dent in the middle, so I had to cut that with a knife, and so I had to leave 3 of those lamels out of it. So that doesn't matter, so as long as you can tighten it up, should be okay. Anyway guys, the former was damaged here on the bottom, so I had to glue it all together and put another piece of board on there with soldering points. So I decided to do some straps to keep the wiring from the coil in place, because they are very fragile. They can break off just like that because that wire is so thin. So I secured that with some straps, and same thing I've done with those wires here, so they can now go underneath and go into that hole and be very secure, so have no trouble of using that. So I'm going to show you what the resistance is of our coil, and it's quite high though. There you go, 214 ohms, so that's very fair. So I'm going to put that into the radio, the power supply, and we take it from there. So when I've done that, I'll come back to you, okay? Okay guys, I have them ready now. It's under load when valve is in. So I had to check my capacitors. I put some big capacitors in here. That resulted in that when the valve was in, he wouldn't start anymore, so there wasn't too much of the good. So I reduced the capacitance to 5000 picofarads. That was nearly 20,000, 22,000 actually. That resulted also in a bigger load in current. It was 1.7 amps, and now with 5000 we are with the valve in there about 1.2 amps on 12 volts. So that should be okay. So we are now a bit further in our putting them under stress, say it's not even warm. It stays completely cool. No, that was something I shouldn't do, because there is a frequency going on. I have the nil of the minus still loose from the chassis, so if you get in between you feel the vibration as it were. It's not very pleasant. Anyway, I put a 6 amp let's see, where are here? At my current limited current, just above that is the LED is going to light up, so it is still 1.21. This works well. You can hear them humming. So the frequency is a lot higher than the net frequency, of course. My voltages are okay. They are 300 volts. So you know, it's a phase. They call it in Dutch fasedraaier, and that means you have 0 in the middle, 300 on one side and 300 on the other side. But they are 302 volt on both sides. So my primary for 235 gives me, let's have a look, let's put this meter on, just measure this for argument's sake. It shouldn't be high up, actually. Okay, hold on, just adjust my voltage on the meter. We give 245 volts, so that is not extremely high, so we can accept that 345 volts in a higher frequency. That's fine. So let's hope it will stay together. And we have a lot of trouble, you know. I had a lot of trouble. Easily say this doesn't warm up at all. How is that? So that it seems the transformer working very well, taking that frequency very well too. You can see on this side I put that plug in so to make the connections too, and that works well. So if you have to have 235 on there, 225, you have to remove this, because of that the transistors stays away from the voltage, you know. That's better for them. I made it that way. So if you unplug this from 12 volts, there's another cable. I had the cable on there already. So you unplug that, then they come loose from there, and then you have 225 on. Of 235 on the primary, and the transformer will perform normally. So it's just a safety how you call this, a safety procedure, so to protect our transistors, that's all. Well, if you know, with the vibrators you had to disconnect them as well, because it was in the text of the story, and they put that out. If they don't use the battery, they took the vibrator out and put them on the net, so and put them back in if they needed 6 volt. Okay. So anyway, guys, I'm not gonna stick around in the video. Just keep testing this transformer. See if he doesn't give off the ghost again, that he doesn't go to heaven. Well, transformers don't go to heaven, but they only break down. Okay, I will do that, and I'll come back to you soon with a new video with the 7A, but concerning our receiver. Aligning from our receiver I didn't do. But first of all, guys, I'm going to check this power supply through, that this is working properly, and I have to figure out some things with the transmitter, with the voltages. I really can't make heads or tail of that. So I think I missed some some schematics. I think there are several versions of schematics, so I really can't put it together. Otherwise, then probably, but probably is used as a sort of how you call that, the listening device for your for when you are transmitting. So anyway, I will try to sort that out. You can I will come back to you soon. So anyway, guys, thank you for watching my videos, and thank you becoming yeah, one of the members are watching. So thank you very much for that, and I will see you later. Okay.